So classification of elements. We have said elements are classified into two types. Elements are classified into two types. They are active elements and passive elements based on its impedance value. If impedance value is positive, then it is passive element. If it is negative, then it is active element. So that one more definition for this is passive elements, the current in the both the direction, that is from A to B and B to A, is possible. Current flow from the node A to B and from the node B to A, it is possible. If that is the case, means such elements are a passive. Let us discuss active elements in detail. Active elements are the elements, they have an capability of delivering the source, delivering the power to the other elements present in the network. So active elements, they are classified into independent sources and dependent sources. First, we do discuss what you mean by independent source. Again, independent sources are divided into voltage source and the current source. Current source can be practical source and ideal source. Similarly, current source can be a practical source and the ideal source. Always, independent sources are represented with the help of a circle. So in this circle, we can use positive sign and a negative sign to indicate it as a voltage source. For the same circle, if arrows are used, then it indicates an current source. So independent sources should be represented with a circle. Inside it, positive or negative sign should be used to represent the voltage source. Inside the circle, arrow marks, either upward or downward, arrow mark should be used to represent the current source. Similarly, a dependent sources, a rhombus should be used here. Inside the rhombus, either positive, negative, or an arrow mark should be used. It indicates dependent source, dependent voltage source. Rhombus indicates a dependent source, arrow indicates dependent current source. Voltage source, current source. Voltage source, current source. The difference is independent voltage and current source, dependent voltage and the current source. Circle is used to represent the independent sources. Rhombus is used to represent the dependent sources. We do see what you mean by independent sources in detail. Later we go for dependent sources. Again, dependent sources is further divided into four types. We'll come to know later. First, we do see active elements are divided into independent sources. This is the classification. Again, independent and dependent sources. Active elements, dependent sources, sorry, active elements, independent sources, active element, dependent sources. All right, we do see the first independent sources. Independent sources, as the name suggests, independent sources produces fixed value of voltage or current, and they are not dependent on any other parameter. Dependent sources can be, it can be either a voltage source or a current source. They do produce a fixed value They do provide a fixed value. They don't depend on any other parameter. All right. Independent sources can be further divided into two types. Independent sources can be further divided into two types. They are independent voltage source, independent current source. All right. We do see independent this path, independent a voltage source. First, we do discuss independent voltage source. An independent voltage source produces a constant voltage across its two terminals. An independent voltage source produces a constant voltage across its two terminals. This voltage is independent of the amount of the current that is flowing through the two terminals of the voltage source. Independent ideal voltage source and its VI characteristics are shown in the figure here. We know that circle indicates an independent source, plus and minus indicates the voltage source, and it indicates an ideal voltage source. The reason is there is no loss. A full amount of energy present in the source appears across the load here. So there is no loss. There is no loss, or there is no heat dissipated or energy absorbed by the source here. A full amount of voltage is produced across these two terminals. That's why it is called as an ideal voltage source. That is discussed here. Why it is called as ideal independent voltage source? Because this voltage is independent of the amount of the current that is flowing through the two terminals of the voltage source, and it produces constant voltage across its two terminal. Do you find a straight line here? Can we call it as a constant voltage irrespective of the current flowing through these points? Voltage is constant. That's why it is called as an ideal voltage source. But the internal resistance of the independent voltage source is 0 ohm. We can say, you can represent a 0 ohm. It doesn't have any internal resistance. That's why you are getting a constant voltage across the load here. But the problem is independent ideal sources do not exist practically because there will be some internal resistance. Always, we don't find a constant voltage across the load. Instead, we do find some deviation, so that ideal independent sources are not available practically. In reality, they are not available. So in reality, independent practical sources are available. We do discuss that. So independent practical sources and its VI characteristics are shown in the figure here. What is the difference between previous and this one? Here we do find internal resistance. Source, along with the source, we do find here the internal resistance. Because of the presence of this internal resistance, there is slight deviation from its ideal characteristics. We don't find a constant voltage. Instead, some deviation is occurred here. These are the practical voltage sources. There is a deviation in the VI characteristics of an independent practical voltage source from the VI characteristics of an independent ideal voltage. This is due to the voltage drop across the internal resistance Rs. All right. Next is what? Independent current source. Always it is represented with the circle arrow inside it. An independent current source produces a constant current. An independent voltage source produces a constant voltage. You should keep those difference in your mind. This current is independent of the voltage across its two terminal. We do see its characteristics. So independent current source produces a constant current that you can see here. Okay. The VI characteristics of an independent ideal voltage source is a constant line, which is always equal to source current irrespective of the voltage value. So internal resistance of the independent ideal current source is infinite ohm. Hence, independent ideal current source do not exist practically because there will be some internal resistance. As we discussed in the independent voltage source, we do find internal resistance. Similarly, in case of an independent current source, we do find internal resistance. In case of voltage source, we do find a series internal resistance. In the case of a current source, we do find a parallel internal resistance. So practically, ideal independent current sources are not available. Okay. Next, we do discuss independent practical current source and its VI characteristics. There is a slight difference, deviations of the VI characteristics of a practical independent voltage current source compared to ideal VI characteristics. This is because of this internal resistance. Always in the current source, internal resistor is connected in parallel. In case of an voltage source, internal resistor is always connected in series. That is said here, deviation. There is a deviation in the VI characteristics of an independent current source from the VI characteristics of an independent ideal current source. This is due to amount of current flows through the internal shunt resistor or a parallel resistor, one another same. Because of this parallel resistance, we do find this deviation. You keep that point in your mind. I repeat, in voltage source, internal resistance is in series. In current source, the internal resistance will be in a parallel. In ideal case, internal resistance will be 0. In ideal case, internal resistance of the current source is infinity. But these two conditions are not practically available, so that practical voltage source and practical current source will show a few values of their internal resistance. Okay. Next, we do see the dependent sources. We don't have that much of time, only 1 minute is left.